Video is about LDR, light dependent resistor. These are light dependent resistor which are used in circuit where we are switching on some circuit by light. This video will be a little bit theoretical as well as practical. I will give you a lot of information about this device, LDR. So LDR stands for light dependent resistor. We are writing like this: light dependent resistor or resistance. So the letters L, D and R, they have taken from and then they have made LDR, light dependent resistor. What is a light dependent resistance? This is a resistor which is depending, the value of the resistance depends upon the light. I am going to show you one resistor which is a fixed resistance. I will show you a fixed resistance which is always fixed, either it is in light, either it is in dark. This is a fixed resistance. This is not depending on any light or anything, but instead this is a fixed resistance. You can see some code over here, the color code. The color code is yellow, violet and then black. Yellow means 4, violet means 7 and black means nothing. So means 47 ohm. So 47 ohm resistance this is, and this will always be a fixed resistance. That's known as fixed resistance. We are going to verify its value through multimeter. This is just for showing. Actually, I am just going to show you so that you will understand that this is a resistance of value somewhat 47 ohm. This is not perfect 47. There should be a 10% tolerance or a 5% tolerance, something like that. So it will be something close to 47. You can see 45.9 or 46 ohm resistance you can see. So this is something close to 47 ohm and this is fixed. You can purchase any resistance for a fixed value. These are very commonly used in circuits. But LDR is a special kind of resistor which is used somewhere where we are working with light and dark. Here I am going to demonstrate a little bit theory also, so that you will understand the theory about this device. This is not only the practical or something like that. This will be a theoretical as well as the practical. Here is the LDR. I am going to show you. This is the LDR, and this has a line inside, you can see, and some semiconductor materials they are made up of, and there are two legs or two wires for this device. This is a 2-wire passive device like a resistance, but it depends upon the light, the quantity of light. Very high resistance in dark and very low resistance in the light. So we are going to draw a graph. You can see here is the graph. This is X and Y. We are going to make a graph. So here on the y-axis we are taking the quantity of resistance, from 10 ohm to 10 to the power 8, very high, something 100 mega ohm, something like that. This we are going to take resistance, and we are writing it like a resistance, and the symbol also like omega. And here we are taking from 0.1 to 1000 lux. Lux is the unit of light. This is normally used for light, and if we draw the characteristic curve, so it will be some way like this. This you will see like this. This you are normally looking in the books. If we draw 3 lines across this curve, you can see these dotted lines. Here if we will write dark, the very much dark over here, and then like night, and then daylight. Daylight, you know, as somewhere we are sitting in the room, that's daylight. In the daytime, here is a sunlight where we are sitting, so we will write is like sunlight over here. So it is under the sun like this, and this is daylight and this is dark. So dark, this is in the dark, you can see it is corresponding to here, and this will be somewhat the value 10 to the power 7 or 10 to the power 6, something like that, 1 megohm or 10 megohm, something like that. Very high resistance we are looking at. While in the daylight we are encountering to some resistance, some value like few hundred ohms and or a kilo ohm, and here in the sunlight it has a low resistance under 100 ohms. So it should be something 50-60 ohms, something like that we are encountering to low resistance. This depends upon the LDR type as well as the number and the company manufacturer and the particular characteristic of the LDR. But keep in mind one thing, that in the light it will have a low resistance and in the dark it will have a very high resistance. This is what is a very simple formula for the LDR. This is the graphical representation for an LDR. Some people are thinking in a different way. They are looking in the books and then they are not understanding. Some people are saying that this will be something, current flow will be something like that, and this way the current will flow. So this is not the reality. The reality is these are the two quantities. The people who know these things, they know very well. We are taking values through meter and through light source, and then we are drawing some graph, and then while we are collecting these points, so this is making a characteristic curve like this. So what is lux? Lux is lumens. There are some particular quantity in the lumens. 12.57 lumens is 1 candle power. This is what is the light unit. Candle power is a light unit, as you know. So 1 candle power is equal to 12.57 lumens. Our lamps are characterized in lumens. They are if we see how will be the lux is, if we will take one lamp having something 100 lumens lamp, and we keep it 1 meter away from 1 square meter area, if it will illuminate 1 square meter area, so it will be something equal to 100 lux. 100 lux will be the quantity. This is what is the understanding of the lux. Now we are going to make some practical using this LDR. I have some few LDRs in my hand, some 4 or 5 LDRs I have, and I will show you some detail about it. LDR, we are going to put it on the breadboard, and here we are going to check the reading with a multimeter. We will check the ohm meter, ohm range for this LDR. See, now we are getting some 1.8 kilo ohms. If we will keep it in the light, some way, some angle we should have to give, so it is giving a little less reading. Now I am going to cover it using this cap, and over the cap I just put some aluminum to make it perfect dark. It's not perfect dark, but even it will provide some darkness. And here you will see some 19 kilo ohm resistance, and if I will put my hand shadow on the device, then you can see it is jumping to 84 kilo ohms. So if you will take it to the night dark, it will be very much high resistance then. So if we will put this LDR in the light, it will give low resistance, and in the night dark it will give high resistance. I am telling it, repeating it so that you will understand. This resistance have no polarity. We are going to put one LED with it. We have a very small LED. The anode side I am connecting to the resistance to the LDR, and the cathode side is open. So now we are getting some battery or some source to light it up, to power it up. So we are going to connect it, negative and positive of a 3.7 volt battery, and here is this connection. You can see this light is lighting now. The reason is this LDR is in the light, very small light. You can see this is lighting up, and Now as you can see, this is in light. So now I'm putting cap on, and this is in dark, so you cannot see any light emitting from the LED. So LED has no light at the moment. Now I'm again putting it in the light, the LDR, so you can see the light is there. So now there is no light. The reason is there is a cap on the LDR. Now there is light because there is no light and no light, light and no light. So this is what is the function of this LDR. This was a small experiment we made, but this is not efficient. This is not sufficient to control a 220 volt lamp or something. This lamp you cannot control 100 watt 220 volt using this by series connection, but instead if you are going to make to switch on and off this lamp, you should have to have some other components like relays and trikes to connect it. Through those relays and trikes you can control a heavy load like 220 and 100 watt load, or more than 100 watt load you can control. Now I'm going to explain in a circuit how you can connect a relay to the LDR. The LDR symbol is some way like this. There is a resistance and in the circle, and then there are two arrows. If you will write LDR with it, it will be very much clear then. This is symbolic representation of LDR. Now if we are connecting an LDR in a circuit, so we are going to make a circuit so that it will act in the dark. I mean the LDR should, the light should be activated in the dark, and it will be not activated in the day, something like that. But this is in reverse what I'm going to do it. So if you will reverse whatever these components, so it will work like it will be activated in the dark and deactivated in the light, something like that. So these relay terminals you can use in your circuit, and you can have to have VCC over here and ground here. So by this way you can make your circuit, and you will be able to control your appliances through this relay. Now I will show you some other thing about the LDR. This is a fact that if you are going to purchase some LDRs in the market, nowadays the LDRs are coming defective in the market. You can see this LDR, this is a new LDR I just purchased, and this is not giving any resistance value on the meter in the day, in the night, nothing. This is only showing OL out of limits. So it means that this LDR is defective. This is open circuit. So these LDRs, unfortunately, they are sold in the market. If you are going to purchase some LDR like this, you will not be able to continue your experiment with. So take care and don't purchase such LDRs from the market. Instead, you have to have a good LDR like this one. I'm going to show you how it is behaving in my hand, as it is showing low resistance, as 294 ohms resistance in the day, and if we will take it to the dark, it will increase its value. As now I'm putting my finger on, but this is not perfect dark, but it is still changing the value. So this is what is a simple test of LDR while you are going to purchase. Next, another LDR I'm going to check. This is also good, so it will behave good. You can see this is something 700 ohm. It is showing in day, and in the night it will show more. So these LDRs are good, and you must have to take care while you are purchasing, because if your experiment will go down in first attempt, it will be not good. If you like it, you give a thumb up, and you must have to subscribe my channel and share it with your friends. Thanks for watching.